Hi everyone, this is Sivapriya. I'm doing Master of Engineering in Computer Science and Engineering at VELTECH, MULTITECH, Dr.RANGARAJAN and Dr.SAKUNTHALA Engineering College. I'm presenting my project. My project title was Design and Implementation of Heartbeat Rate and SpO2 Detector using IoT for Patients. And this is my abstract. These days we can get many healthcare systems, but people who are living in territory areas will not get any medical services due to no specialist or private clinic. So we implement the heartbeat rate and SpO2 detector device which used to measure SpO2 heartbeat rate and temperature ranges. And the person can see their heartbeat rate, SpO2 and temperature ranges in their Android mobile through the OP app which gets the ranges through Bluetooth connection with the heartbeat rate and SpO2 detector device. Now everyone having the Android mobile, so they can easily use the detector device and OP app. Once the person ranges viewed in the OP app, they can interact with the doctor, and the video conference can be done on the same OP app. The person can contact the doctor from anywhere at any time. There are many healthcare systems are there to monitor health parameters. There are wireless sensors, wearable health monitoring systems, and many others are there in the market. But most of them are difficult to carry from one place to another and uncomfortable to wear every time. And the other system would not connect with the doctor for consultation. We'll see some of the existing systems. This is designing and implementation of microcontroller-based non-invasive health monitoring system. This system measures human body temperature, heartbeat rate per minute, and blood glucose level. This one uses different sensors to measure those parameters, which are LM35 temperature sensors, gas sensors, and pulse sensors. And the second one is the Narrowband Internet of Things system for elderly healthcare services. This system mainly helps the elderly people and the disabled people. It detects and gives alarm if they fall down with the help of gyroscope sensors. The smart health monitoring system through IoT, just same like the first one, it measures different health parameters, but it stores those monitored data in cloud. This IoT-based remote health monitoring system for patients and elderly people has three sensors to monitor the patient's heart pulse rate, body temperature, and galvanic skin. Here, they has to calibrate individually. This system heartbeat rate detection method based on IoT and monitoring system using Arduino Uno and ThinkSpeak. It helps to measure pulse rate, peak systolic pressure, and baseline systolic pressure. In existing system, medical care system, that are difficult to carry and uncomfortable to wear every time, and some are large and needs lot of cable connections too. And one more main problem is people's avoiding to go hospital due to travel expense and time and unwanted tension. So, through the heartbeat rate and SpO2 detector and OP app, the abnormal health condition of the patient can be quickly monitored at home. The vital sign monitoring system measures the SpO2, heartbeat rate, and body temperature of the patients, which also can be viewed in OP app. The same can be viewed by the doctor, and the doctor and patient connection done through the video conference. The main advantages of the proposed system is the heartbeat rate and SpO2 detector is not much expensive, and it's an open source system easy to use. By using OP app can overcome all drawbacks in existing system. This is my system architecture. Here you can see the virtual sign monitoring system on the left side. This is our first stage. The person have to place the SpO2 probe on the person's finger, which has to be in relaxed mode. The second state, the pulse oximetry microcontroller, a photo detector, and thermostat which are available in the detector device, which are used to measure the ranges of the person's health. The ranges are measured through the light absorption between the fingers and sent to the OP app through the Bluetooth module which was connected in the detector device. If the ranges are high, it sends push notification to the doctor's mobile, and then the available doctor can contact the person back and video conference can done through the OP app. For each, we have separate database. For patient on database and for the measurement, we have separate measurement database, and for the doctors database, and admin using the same different admin database which are accessed to the cloud. The patient can connect the doctor at any time and anywhere. This is a data flow diagram. This is a data flow diagram. The SpO2 probe and temperature probe which connect together with the microcontroller through the USB cable. The ranges are passing to the Android mobile and to the which can be viewed in the OP app. Once the ranges are measured, we can view the ranges in the OP app. If it's high, it will send push notification to the doctor's mobile for the consultation. Here we are using here there are three modules are there: SpO2 detection module, heartbeat rate detection module, and temperature detection module. First, let's see SpO2 detection. It defines amount of oxygen present in our blood, which is based on hemoglobin and deoxyhemoglobin. The pulse oximetry is a non-invasive and an indirect device to measure the oxygen saturation level. The function by two light sensors, which are red and infrared light, and calculate with the help of Beer's law. This is our SpO2 detection data flow diagram, which includes the pulse oximetry and Beer's law, and the OP amplifier, which converts the current to voltage, which helps to measure the level of SpO2. That means oxygen saturation level. Why SpO2 is more important? Because it measures the level of oxygen present in our blood. For every patient, first the SpO2 level will be measured by the clinician doctor. Some amount of oxygen must be present for the patients. Mainly for the patients who are affected by profound respiratory failure, pulmonary hypertension, chronic heart failure, and kinetic congenital heart disease. Heartbeat rate, the next module, heartbeat rate detection. It can done with the same SpO2 probe through the pulse oximetry. The number of time heart beats per minute is measured with the help of pulse waveform. The pulse rate was calculated. The pulse oximetry works on by using two different lights. You know already it's a red light and infrared light. This is our data flow diagram for heartbeat rate detection. It's similar to SpO2 detection. At the end, it will show the heartbeat rate ranges. Why heartbeat rate is so important? If heart rate reaches dangerous level, the person can cause heart disease and sometimes it leads to cardiac attack. The slight changes in heartbeat rate will not affect, but with faint or dizzy or breathing problem, The patient should connect with the doctor for the consultation. This is third module, temperature detection. Measuring body temperature helps to suspect many infections. Here thermistor is used with probe. It contains resistance. The resistance changes according to the temperature changes in our human body. The data flow diagram shows the voltage drop across the resistance will helps to measure the body temperature of the patient. Pulse oximeter, which helps to determine the necessity of sending patients to specialist hospital. This is a non-invasive method and it indirect device to measure the oxygen saturation. Most of all, the chronic respiratory failure patient must use the home oxygen therapy by a physician. So, the pulse oximeter is the best one to measure the oxygen level of the patient. The Beer's law. The principle of Beer's law is the amount of light absorbed is proportional to the concentration of the light absorbing substance. The level of oxygenated hemoglobin and deoxygenated hemoglobin are worked out by the ratio between infrared light and the red light. This is our registration page. For a doctor, it has separate one, and for patient, we having separate registration. There are two different registration pages, one for doctor and one for doctor. This is the coding page, how we getting the details of patient and doctor. How it works. This is our activity registration page, how we are getting the details of the patients or a doctor and how we are going to allow them to log in. This is our login activity, how the current to get the current user, to get to see who are available at that moment, which doctors like that. This is a SpO2 detector device. Now you can see the Bluetooth module is attached with the device. This is the app page. This is a doctor patient page, and if we click doctor, you can see login and register. The same for the patient, login and register. Once you get you select a register page, you will get the like this. And here if you are the doctor has to enter every details and have to submit it. Same like for the patients. And once the login activities are finished, then for the patient it will ask to switch on the Bluetooth, and if you connected with the detector device, it will show here. You can see the heart rate and SpO2 detector here. Once we select that one, it will start to record the read the values. If you didn't connect the probe on your finger, it doesn't show any measurement. It will show only that heartbeat rate like that. Once you started to connect, it will show everything on your page, like your name, your details, and your ranges, your numbers, like that. And the doctor can see who are the patients available on that moment, who are need helps at that moment. And here, most of all, that the heartbeat null, they doesn't need. If it's high, they can see easily that patient needs emergency to consult for the consultation. So the doctor will select the persons, and you can contact like contact with a video conference with the patient. The patient doctor consultation can be done through the video conference. These are my reference papers. Thank you very much.